All right, welcome to 12.4 part 2. So we're going to do some more examples with probability and overlap, as well as trees. So this first example is kind of an extension of last time. So you are performing an experiment to determine how well plants grow under different light sources. Of the 30 plants, all right, so that's going to be a key part of information. We have 30 plants, 12 are receiving visible light, 15 are receiving ultraviolet, and 6 are receiving both. So what is the probability? So what it's asking is the probability it receives visible or ultraviolet light. So probability of visible or ultraviolet. This is a compound event because it has overlap. So we're going to do the probability that it's visible plus the probability that it's UV minus the probability that it is both. The key of this is it's saying 12 receive visible light. It's not saying only 12. It's saying 12 in total receive visible light, so it's counting that 6. That's why we want to subtract it. So 12 out of 30 plus 15 over 30 minus 6 over 30 gives us 21 out of 30. Or 7/10. So 70% of the plants. And in that case, 3/10 aren't receiving either. Now we're going to use trees. Definitely looking at the notes to make sure you can see all of this. The notes online is going to help you here. So the ADA estimates that 8.3% of people in the United States have diabetes. Suppose that a medical lab has developed a simple diagnostic test that is 98% accurate. All right, so there are some important numbers here. So 8.3 have diabetes. A test is 98% accurate for people who have the disease and 95% accurate for people who don't. So if they have it, it's even more accurate. If you don't have it, it's a little less accurate. So we use a tree because I want to know the correct diagnosis. Now, correct diagnosis means I want the probability that you have diabetes and it's a correct test, or the probability that you don't have it and it's correct. So I have to find those probabilities together. So I use a tree. That is the best way to do it. So we start with the basics. 8.3% of people in the United States have diabetes. So you're a person. You either have diabetes or you don't have it. If you have diabetes, that's a 0.83% chance. That's how we go from percentages to decimals, we divide by 100. Which means the chance that you do have it would be 0.917. So these add up to 1. So that's the beginning. Somebody either has it or doesn't. Then it depends on is the test correct or not. So you can have it and the test is correct or incorrect. Or you could not have it and the test is correct or incorrect. So the chance that you have it and it's correct, 98% accurate for people that have it. So that's 0.98, which means it's 0.02 incorrect. Or you don't have it and it's 95% accurate and 5% inaccurate. So, what's the probability that you have diabetes and it's correct? Well, for something to be and, we multiply. And you want to multiply across the branch of the tree. So have diabetes and it's correct. So 0.083 times 0.98. .083 times 0.98 gives you 0.081. So 0.081 or 8.1% of the time, someone will have diabetes and the test will be correct. I also want to know the probability that they don't have it and it's correct. So they don't have it, that's 0.917 times the test is correct, 0.95. And that gives me 0.871. So there's an 8.1% chance you have it and it's correct. There is a 0.871 or 87.1% chance you don't have it and it's correct. So together, there's a 0.952. So the test is going to be, you're going to get a correct diagnosis 95.2% of the time. So we're going to do another practice with these trees. So first, so a high school basketball team leads halftime in 60% of the games. All right, we lead halftime at 60% of the games. And a team wins 80% when they have the lead and only 10% of the time when they don't have the lead. So, I want to know the probability that the team wins. So, first, they're either have the lead at halftime or they don't lead at halftime. And then after that, they either win or they lose. So, the team leads at halftime 60% of their games. Now, up and down should add to 1. Each split should add to 1. So that means they don't lead 40%. Okay? And then, win and lose, they win 80% of the time that they lead at halftime, which means 20% they lead and then lose. Only 10% of the time, they only win 10% of the time when they don't lead, which means 90% they lose. So, what's the probability they win? Well, it's the probability they lead and win, or the probability that they don't lead at halftime and still win. So I want to multiply across. What's the probability that they lead in halftime and win? 0.6 times 0.8. multiplying across the branch, and that's 0.48. And then there's a chance where they don't lead, but they still win. So that's 0.4 times 0.1, 0.04. So this basketball team wins about 52% of the time. If I asked how often they lose, you would go across in that way. So now please do your 12.4 homework, and after this there is only one section left, 12.5. We've done it almost.